Miss Ramirez, and in this segment, we're going to be exploring thermal energy. Thermal energy is just heat energy, and heat energy is just energy that makes things warmer. Typically, heat energy will move from things that are warmer to things that are cooler. So in this segment, we're going to be looking at a variety of different things that generate heat energy. Most of these things will be using electrical energy and converting it over to heat energy that we can use to help us do a variety of different things. So we're going to be using our senses of touch and sight to help us explore thermal or heat energy. So the first thing that we're going to look at is a very common kitchen appliance that you guys probably use. I know I use it in the mornings. So this is going to be a toaster. A toaster is a kitchen appliance that converts electrical energy into heat energy. So if you've ever had a slice of bread that you take out of a package, when you touch it, it's kind of soft and flimsy. When you put it in the toaster and it heats up, it turns into that nice crunchy piece of toast that we can enjoy for breakfast. So that's how a toaster uses heat or thermal energy to help us cook foods. Another kitchen appliance that you guys are probably familiar with is a stovetop. Now, I have a portable version of a stovetop. This one is an electrical version, and I can put a pot or pan on here, and I can cook some rice or pasta. And the rice or pasta, you notice a change. So when the rice or pasta is not cooked, it's kind of hard. And then when you cook it, it becomes nice and soft so that we can eat it. So that's our stovetop. Another appliance that I use, especially during the winter time, because I don't like being cold. So I like it to be nice and warm in my room. I have lots of these little space heaters. These are very helpful in my bathroom. So I just plug it into the wall, and it gives off some nice thermal or heat energy. Another thing that I'm using right now is actually an electric blanket. So this is an electric blanket. I have it plugged in, and it's on the highest heat setting. There's actually wires that run through here, and it's helping to make this blanket nice and warm. So I actually stuck a thermometer inside this electric blanket, and it got up to over 120 degrees Fahrenheit. So a science tool that we can use to measure the amount of heat energy is a thermometer. So a thermometer is just a science tool. It can tell us the degrees in temperature. It can tell us degrees Fahrenheit or degrees Celsius. So my electric blanket is probably the best thing I ever got for Christmas, and it keeps me nice and warm. And again, it's a toasty 120 degrees Fahrenheit. Now I have something else to show you guys. We're going to compare an electric blanket to a regular blanket or to a coat or jacket that you guys might be wearing pretty soon since we're in fall. So let's take a look at my shawl. Do you guys think my shawl or my wrap provides or generates heat or thermal energy? So the answer to that is no. So the way a sweater or a jacket or my shawl, the way these things work is they help to trap our body heat. So when I put it on, as Mr. Broughton and Mrs. Fuller mentioned before, our body is constantly losing heat to the cooler environment. So the way my shawl works is when I put it on, it's actually trapping that escaping body heat, and it's keeping me warm that way. But it does not generate thermal heat the same way an electric blanket would. So that's the difference between those two. So coats and regular blankets are what we call insulators. The next thing we're going to talk about are some common toys that you might see at the toy store that use electric energy to convert it into heat. So the first thing I'm going to show you guys is this lava lamp. So this lava lamp has a bulb inside. Not only is this lava lamp producing light energy, but it's also generating that heat energy. And that heat energy is what's making the water and the glitter move up and down. So generally, things that are hot, hot air will rise, and then when it cools down, it will sink down. So this is how a lava lamp works. I'm actually going to use my other lava lamp to better demonstrate that movement of hot and cold particles. So I'm going to put on my safety mitts. A good thing when you're dealing with thermal or heat energy is to always think about safety. We don't want to touch things that are going to be super hot because we don't want to burn ourselves. So always think about safety. If you're in the kitchen, always make sure you have an adult nearby. So here is my other lava lamp. I'm wearing the mitts with this one because for some reason this one gets a lot hotter on the bottom. There's a bulb inside. So when I plug this into an outlet, the light turns on and it generates a lot of heat. energy. That heat is causing that yellow fluid to get hot. When it gets hot, it starts to rise like that one you see here. So hot things rise. Then when it gets cool, when it gets to the top, it cools down because it's further away from the heat source. So you can see this blob over here is starting to cool down, and so it's going to sink to the bottom. When it sinks to the bottom, it's going to come closer in contact with that hot bulb, and it's going to get hot all over again. And the whole cycle will continue, and that is how we see that movement in a lava lamp. So the big science word for that is convection, but you won't learn about that until later. So that's just how a lava lamp works. Another science tool or toy that you guys might have seen before are these color changing boards. They use them a lot in the little grades. The kids can write things with their fingers. It is a heat sensitive board. So just like Mr. Broughton and Mrs. Fuller mentioned, we do produce and give off body heat. So I'm going to use the body heat from my hand to make an imprint on this heat sensitive film. So hopefully my hand should be warm enough since it was on that electric blanket. So here you can see my body heat left an imprint on this heat sensitive film. So I'm going to put that one back. And just a couple of things with our safety, just a reminder. Again, you can use oven mitts if you're in the kitchen, and if you're touching hot foods, you can also use tongs. So again, safety is very important when we're dealing with thermal energy. The next thing we're going to look at is how thermal energy affects our animals here at the Environmental Center. So I actually have an animal friend that I'm going to show you guys. This animal friend is Pelota. She is a ball python snake. And she gets that name because when she's scared, she can actually curl into a nice tight ball so that she can be hidden. So the reason I'm showing you guys Pelota is because she is a cold-blooded reptile. So reptiles are cold-blooded, and all that means is they cannot maintain their body temperature. So if they feel cold, they're going to have to go and find some place to get warm. They're going to have to find a heat source. So humans are mammals. Mammals, they are pretty good at maintaining a pretty constant body temperature. So the problem with our reptile friends is if they're hot, they're gonna have to find a place to cool down. And if they're cold, they're gonna have to find a nice heat source. So I'm gonna go ahead and put Pelota back, and I'm gonna show you an example of how we take care of our reptile friends to make sure they have the right amount of heat that they need to stay nice and warm. So I'm gonna kind of move my laptop just a little bit so you can see this. This right here is a terrarium. You guys have probably seen an aquarium before. So an aquarium is filled with water, and it's where our fish and other aquatic or water animals live. A terrarium is for our land animals. So on this terrarium, I have a heat lamp. Inside the heat lamp is just a bulb that provides heat energy. And then when Pelota or when another reptile, if they're feeling cold, they'll just move over and they'll bask underneath the heat lamp. Once they're nice and warm, then if they want, they can always move back to the other side and cool off. So I can actually use my sense of touch. I can touch the glass and I can feel a change in temperature. The glass on this side by the heat lamp feels a lot warmer. The glass on this side without the lamp feels cooler. I actually put thermometers inside, and the temperature under the heat lamp is about 100 degrees Fahrenheit. So that's like a hot summer day. The temperature on this side is about 74 degrees Fahrenheit. So that's about room temperature. So there is a difference. And that temperature difference is what our reptiles need to help them stay nice and comfy. So they can move from a hot side to a cool side whenever they feel needed. Now, since y'all aren't able to visit us today, I'm going to share my screen and I'm going to show you a couple of pictures of some of our other reptile friends that depend on heat energy. This one is a box turtle. You can see that he's enjoying that nice heat from that heat lamp. This one is a red-eared slider. They get that name because they have a red patch of skin around their ear. This is a prehensile-tailed skink enjoying that nice night light. This one is a close-up, and you can see, again, our reptile friends all have dry, scaly skin. Now, this one is not a reptile. It's a bird, but a bird is also warm-blooded, just like us. But the reason this little baby bird has a heat lamp is because the baby birds, they're very delicate, and they need that extra warmth when they're young. So that's why he has a little extra heat lamp, just to help keep him warm until he gets a little bit bigger. And there's a picture of a close-up of him as well. Now, Mrs. Fuller mentioned our son. Our sun is the main source of heat energy outside, and that heat energy is very important for keeping all of our wildlife and us nice and warm. It also helps our plants grow, and it also provides light energy as well. And again, it's important for our water cycle. So I'm going to go ahead and stop sharing our screen, and we're going to go back to our presentation mode. And then I have one last thing that I want to discuss with you guys, and that is just a quick little challenge. I want to see if you can look around your home or apartment and see if you can find something that generates heat or thermal energy, and then describe how do you use it or how is that helpful to us. So think of this question stem, and you're going to fill in the blank. The blank provides thermal energy to blank. So find something at home that produces thermal energy, and then describe how do you use it and why.